So welcome everyone to this lecture in the context of the lecture series Manuscriptology and Digital Humanities, which is a collaboration between the Classical Indology Department here at Heidelberg and Otani University with Professor Shobha Das, who is also attending this meeting here. And we are really happy to have a presentation today by Sebastian Nehrdich, who will talk on Dharmamitra, and the title of the talk is New Tools for Sanskrit Translation, Grammatical Analysis, Search, and Digital Philology. So as you can see, the room is full and is getting fuller. So this already is a very, very good hint at the fact that this is really a topic that is of great relevance to all of us. I mean, especially with the radical improvement or at least development of artificial intelligence, which now evidently is also pertaining to us as Sanskritists. We thought for a long time this will happen only very, very late in the development, but clearly with Sebastian Nehrdich and his project, it is not. Sebastian Nehrdich is at Berkeley University, and he is interested in machine learning and natural language processing. At the same time, he also has studied Indology and Sinology at Hamburg University. So he's one of the few persons who combine expertise in many relevant fields. And he has developed or has co-developed this Dharmamitra program. And before I say something that's totally out of line, I would say, Sebastian, we are very much looking forward to your presentation and to the discussion afterwards. So I would just leave the floor to you.
Yes, thank you. Thank you so much for the kind introduction. And yeah, I have to warn in advance because it's 12 a.m. here. So if I get a bit sleepy during my talk, I have to excuse. Please wake me up if that happens. And yeah, but thank you a lot for the invitation. I'm very, very happy for the opportunity to present our project here. And yeah, I think I will just start to share my slides now. I hope everything is visible and all participants can see. Okay, great. Yeah, so I'm presenting the Dharmamitra project, which is hosted here at UC Berkeley, and it has been started. So we started our work in 2023, roughly 1.5 years ago. So in April 2023, and we published our first usable models, I think, just roughly 1 year later after the start of our work, and the grammatical system was added this summer. So it's all pretty fresh what I'm presenting right now, and there's a lot of ongoing work here. It's a very young project. I think in the life cycle of academic projects, probably really young, and we really hope to mature over time, but I'm very happy that we can already present something at this early stage. My presentation will have 4 different parts. So the first one is the machine translation system. The second one is the Sanskrit grammatical analyzer. The third one is the semantic search system, which we are currently developing. So that's not yet publicly available, but that's going to be one component that we are adding in the coming year at some point. And then the Mitra LLM, we call it the Alaya LLM for those of you who are studying Yogacara Buddhism. This might be something familiar. It's the base model that we use in order to make all the different functions of our website possible. So that's the last part of my presentation. First of all, to introduce the team. So who is Mitra, who is behind that team, and who's doing what? So on the one hand, we have Professor Kurt Kreutzer here at UC Berkeley, who is a specialist on AI and machine learning for many years. So he has been around in computer science for decades, and he was there when the first deep learning models in 2011, 2012 were really taking over the field of computer vision, and since then he has been on the forefront of AI research. But at the same time, he's also a scholar of Tibetan Buddhism, and he has studied Tibetan for many years and Sanskrit as well. So he has a strong interest in Asian languages, in Buddhist text, and in Dharmic text in general. So that's the special interest that drove him to initiate this project. And then there's myself. I'm doing the technical supervision of the project, the heavy lifting of the machine learning, the different models, the integration of all of that into our website, and so on. So that's my part. Then we have David Alport, who did a PhD in Sanskrit at Oxford University, actually, I think in the early 80s, and he later switched into AI research at a time when AI research was not yet as fancy as it is nowadays. So he has done it in the late 80s, in the 90s, and throughout the 2000s. So we are very happy to have him. He has been in the Silicon Valley for many years and joined this project now to do Sanskrit data collection and to help refining the models that we have and so on. So we are very happy for that. And then Jivnesh Sandan, of course, some of you might know him. He has also worked extensively on NLP applications for Sanskrit, and he has been a partner of the project since the early start. So we have been collaborating on training models and on conceiving papers on machine translation. So that's Jivnesh. And then we have two undergrads here at UC Berkeley, Neil and Avery, who are working on smaller sub-projects on the search system as well as the automatic evaluation of machine translation systems. And not mentioned on this slide, but we do have many more high school undergrads or generally interns that joined the project for shorter periods of times. You can see a list of faces on the website if you want to check that out. Now I will turn to the first part, to the machine translation system. I mean, it's easy to access. You just have to go to dharmamitra.org and you can start to play around and to use it immediately. I think there's not too much that needs to be explained about that. I can show the translation system in action in a short video if you just want to see how it functions. So this is a version that we are currently developing, and it will be released in the next week or two, where we, on the one hand, provide the machine translation, but then also a grammatical analysis that uses our grammatical engine together with the translation system in order to also provide explanations that accompany the machine translation. So right now you see the machine translation on the website, and this explanation function is going to be added in a couple of weeks. So what does this Mitra translation system actually mean? What is it built for, and what is it doing? So the main languages that we are focusing on is Sanskrit, Tibetan, Chinese, and Pali. And the main target language at the moment is English. We do offer other languages, but the support is generally not as good as for English, because we are a constrained team. We can only evaluate and improve on so many ends. So right now, my recommendation is to use English. We have a considerable user base in Korea, actually. So the translation system into Korean is also, I think, coming along quite well. For the other languages, it's a bit, you might try that, but be aware that maybe the performance will not always be as good. We offer grammatical explanations for Sanskrit. We have plans to add that for other languages as well, for Tibetan and for Chinese, but currently we only offer this for Sanskrit. Mitra is currently the state of the art, so that in computer science terms, that means the best available solution for Sanskrit, Tibetan, and Chinese to English machine translation. So we have done systematic evaluation using machine translation metrics in order to determine the performance. And in our overall evaluation, I think Mitra comes out at the top compared to Claude and GPT and these other models. And I will show a slide on the performance on different domains after this one. Mitra has between 700 and 1,200 unique daily users. We are serving between 5 and 15,000 daily translation requests. So that's roughly the kind of volume that we are processing. Yeah, coming to the machine translation performance. So for those of you who are not familiar with machine translation evaluation, so the easiest way to determine how good a model is performing is to collect reference translations, text pairs of Sanskrit text and English translations, and then to compare how the model is performing when it does the same task. So we give the model a Sanskrit text and we ask it to translate, and then we compare the similarity of the translation that the model has generated with the reference translation that we have collected. And it's a crude way to measure this translation quality, and not all nuances are always captured, but it at least gives us a rough direction of where the model is heading. The score here is CHRF, which is a character-based comparison score. And as you can see, Mitra, which is the blue bar, comes out on top. So the higher score means better performance for all of these domains. And we have evaluated this on a number of different domains. We have the Bhagavad Gita, of course, Vimalakirti Nidesha, Buddhist text, Buddha Charita, but also Skanda Purana, Brahmana, Satapatha, Brahmana, Rig Veda. So we really try to sample widely from the entire different Sanskrit domains in order to have a coverage that goes into all of these domains. And I think another noteworthy observation of this graph is that actually the performance of Claude 3, 3.5 is very similar. So that's the orange and the green bar. Also GPT-4 and GPT-4 Turbo are very close to that. And that sometimes I have my doubts if maybe the data brokers of Claude and GPT might have the same source. There's some reason to be suspicious about this. And then Google Translate is visibly doing not so well. I think that's that can be said, that the performance of Google Translate is really falling off. And I think that's also confirmed by user feedback so far, that those people that I have talked with prefer to use Claude over Google Translate or GPT as well. So it seems to do not as well on the Sanskrit task. Yeah, coming to the Mitra Sanskrit grammatical analyzer. So the one way to use that at the moment on the website is if you enter a Sanskrit sentence, then you will get a small button at the bottom of the screen that says grammar. And if you click on that, then you get this sidebar menu that opens up. And this will provide you with a word segmentation of the sentence, and compounds are indicated with this hyphen signal here. And then you have grammatical tags like the tense in the case of a verb. In this case, we have tense, mood, person, and number. We also have the lemma form of the verb, and you also get meanings that are basically fetched from Monnier-Williams dictionary that Oliver Helwig matched with his corpus. So this is work that he has done in order to match the lemma forms with the dictionaries here, and that's the kind of data that we are pulling in here. It would, of course, be extremely desirable and interesting to also add, for example, the Abte dictionary or Petersburger Wörterbuch here, and that's kind of one of the ongoing directions to explore if we can see that we have a wider dictionary coverage at this point. We also have a Google Chrome extension since a couple of weeks. This is a new tool. It's actually quite easy to install. You just go to the Google Chrome web store and you look for Dharmamitra, and then you should get this extension to install. Installation is really straightforward, and once you have done that, you just have to mark a passage in the text. In this case, I have marked this verse of the Mula Madhyamika Karika, and then you can either do a right click and say analyze with Dharmamitra, or you click on that a wheel symbol here in the extension sidebar after you have installed it. That should appear, and then when you click on that, you will get this this window opening, which will give you on the one hand the machine translation of the sentence, but then also the grammatical analysis that we offer on the website as well. So this is just a convenient in web browser version of what the website offers. So the functionality is completely matching up. There's between the two. And I think the nice advantage of this Chrome extension is that you can actually use it with whatever database you are comfortable with. So if you look at the e-text directly in the Gradle repository, then you can just do that and use our extension, or you use Buddha Nexus, BDRC, the Digital Sanskrit Buddhist, Digital Buddhist Sanskrit corpus, and so on. It should work well with all of these resources. So that was a bit our idea, to have something that integrates well with other databases. For those of you who use Emacs, I know that's probably a very small subset of the audience here. I just want to mention we do have an Emacs extension. I myself tend to use Emacs sometimes, so I think it's kind of funny to be able to use this tool also inside of Emacs. So yeah, that's actually on GitHub. So if you just Google for Dharmamitra Emacs, you should find this link quite easily. So what is behind this grammatical explanation system? That's of course the big question. So the annotations are based on Oliver Helwig's digital corpus of Sanskrit, and that's a wonderful resource and a great achievement of Oliver, without doubt. And we have used this data from the DCS in order to do the fine-tuning of our annotation model. So whatever annotation you see created by this grammar model, it will follow that DCS conventions. Oliver and I have recently released a Sanskrit NLP model that we call BT5 Sanskrit, which performs Sandhi and compound segmentation, lemmatization, and morphosyntactic tagging jointly in one task. I will show a bit more on how that works on the next slides. Yeah, and this model is currently the state of the art for Sanskrit grammatical analysis by a considerable margin. So we have done a segmentation paper in 2018, and I think the current model really is about 50% less error, less likely to make an error than the previous one. So we have kind of reduced the error rate by 50%. And this leads us to an error rate that is roughly as high as a single human annotator. So if you ask a human to do a grammatical annotation of a Sanskrit text, somebody who is decently educated in Sanskrit, what you get and what this model is producing is somewhat on a similar level. Of course, if you do revision, if you have multiple annotators, that is a different story. But what our model produces is getting to a similar level of quality compared to a single human. Our system is available as an API that serves up to 10,000 sentences per minute for corpus-wide annotation tasks. And I think this is something that could be interesting for projects that need to process larger amounts of Sanskrit data in order to do search applications, analysis of Sanskrit text, all kinds of things where you need to have a segmented and grammatically analyzed version of the text. So we are very happy to collaborate on that. So if you want to use this tool, then feel free to just reach out to us. We are more than happy to help any project that has the need to use this. If you want to read a publication on this, so we have this recent EMNLP findings paper where all of this is described in more detail on the technical level. And yeah, I will just briefly summarize these details for those of you who are interested. So we have a pre-trained character level language model that is a transformer architecture, as more or less all NLP models are in the recent couple of years. We have 580 million parameters, which is comparatively small. I think compared to average open source language models nowadays, which have 7 to 13 billion parameters, this is really a small model. And compared to what OpenAI and other big companies will provide, this is absolutely tiny. So it's the size that runs comfortably on a laptop, on a modern laptop. So it's also possible to run it locally if you are a bit more like technically adventurous and want to try that out. I think any like decent Apple computer should be able to handle this, for example. We have reformulated the task of word segmentation, lemmatization, and morphosyntactic tagging as a sequence generation task. That basically means we do a sequence-to-sequence approach here, where we turn an input string into an output string, and the model has an encoder and a decoder. So it's very traditional, actually, in that sense. Yeah, and since we are using a character level architecture, so we are not using any tokenizer, we work directly with the individual characters, we had to do some tricks in order to get the lengthy universal dependency tags, which sometimes can be 100 characters long for a morphologically rich language like Sanskrit. We had to compress them into a shorter representation in order to make the model work. And for this, we used just unused letter combinations of the IIST alphabet. That is something I can show here. So you can see you have the lengthy tags up here, and then we represent each of these grammatical features just by an uppercase letter, S for singular and N for nominative and M for masculine gender, for example. And then we just made sure with the dictionary lookup that we have no ambiguities in these abbreviations. And in that way, we can compress the whole morphological information in a very, very short string, which makes it possible to process longer sequences without losing any kind of information. Yeah, so that's here about this architecture. We have also done a bit of feedback. So there's one translation group, the Kumara Jiva project. It's kind of difficult to find people who do systematic reviews and feedback of these kind of systems. So we were very fortunate that the Kumara Jiva project, which is working on translating the Tibetan Buddhist scriptures into Chinese, but they also have a lot of need to work with Sanskrit while doing that. So they were actually offering their help in order to evaluate the usability of our system. And this is a small sample size. We had only 6 responses from them. So 6 of their professional translators have agreed to give feedback. And all of this feedback was done extensively in the form of interviews. And then finally, we asked them to summarize their experience on a scale of 1 to 10, while 1 is, okay, this is not helpful at all, and 10 is, okay, this is very helpful. And as you can see, all of these translators have agreed that this is helpful to them. So they have all given a score higher than 5. And even 3 of them said that this is really very helpful, so they gave the highest score. So that is an indicator that obviously translators seem to see some value in having these tools available. But I'm of course also happy to hear the feedback here in this meeting and to hear how other people feel about this. I'm sure not everybody is really benefiting equally from this, and that's totally fine. And yeah, we are very happy to just hear what people are making out of this system. Coming to the semantic search part, which is not yet officially released, and I think the timeline for this could be anything between 2 to 6 months. So it will take a bit of time until we can make that public. But since we are talking about philology here and about possible applications of deep learning in that direction, I'm very happy to give an introduction on how we are approaching that problem. Because, yeah, while I was at Hamburg University, I was working on this manuscript, which was a very fascinating philological problem. It's the Madhyanta Vibhaga Tika, and it was burned to roughly 1/3. And the interesting thing is that the missing parts are always just one part of a line. So it's not really we have multiple folios missing. I mean, that might also be the case. I don't remember clearly if the manuscript was complete. But the more challenging part was that each of the folios had 1/3 missing. So we needed to reconstruct these gaps. And they are, in a way, not too long, not too short. So they are certainly too long for in order to make the reconstruction trivial, but they are also short enough that we can do something with computers in order to accelerate the process. Unfortunately, we had a full Tibetan translation, which helped a lot to get an idea of how these gaps look like. So the basic problem that I got tasked with at that time is to reconstruct these 30% of each line. And I had the fortunate situation that I met a friend at that time who was a professor for computer science and linguistics in Bremen. And he told me, okay, this looks like something you could work with computers on. So that's how I actually got into contact with Oliver back then in order to see what we can do to design algorithms that can help in this kind of problems. Yeah, so these gaps are generally not too large. Then we have a complete good Tibetan translation that helps us. We do have nowadays also plenty of electronically available e-text of Abhidharma and Yogacara material, which were not available at the time of Yamaguchi, the first edition. So that's of course great because we have a bigger data store to search in. And then also in many cases, these reconstructions can be done with evidence from within the same text. I think this kind of leads to more general problems. So we have this narrow philological problem of this one manuscript, but there are underlying problems that are more general, and I think that are in the larger field of Indology, Buddhist studies, kind of prevailing. So the one problem is, how can we find related passages across different texts that are preserved in different languages? And when I was an undergrad student, this was still what people told me what I should do, is I call it the pocket calculator method, by applying the rule of three. I think in German we call it the Dreisatz. If you have a book in Sanskrit, the Sanskrit edition has 150 pages and the Tibetan version of that has 200 pages, then you can roughly calculate, okay, maybe if I'm on page 71 of the Sanskrit text, then I need to be on page 95 of the Tibetan text. And okay, then you still have to flip a couple of pages around in order to find where you should be looking. But this is, of course, obviously imprecise, it's time consuming, and depending on the situation, it still can take half an hour or so to really find the right position. And then, of course, we have digital databases for this kind of problem right now. So there's Bibliotheca Polyglotta, which is a great resource. Unfortunately, for the kind of work that I was doing, it was limited in material. So there was, at the time when I was working on this, I think the Abhidharma Kosha Bhashya was not entered completely, at least not the Tibetan Sanskrit version. And the Vakya was not available at all, and Yogacara Bhumi and so on. These important texts were not available. So that's the one part, is finding these multilingual corresponding passages in order to help with the reconstruction of the manuscript. But then we also have the related problem, which is, I think, a little bit easier to tackle, is to find similar passages to a given input phrase within the same language, to see if there's a passage from the Abhidharma Kosha that matches the Madhyanta Vibhaga Tika, which then gives us a better idea on how to do the reconstruction. And this is something we have published earlier in the form of the Buddha Nexus database at Hamburg. So while I was still studying in Hamburg, that is a work we have done with Orna Almogi and Dorji Wangchuk. So the outcome of that monolingual similar passage retrieval was already published in that form. And then lastly, the other related problem here is Q&A. So this is something that I didn't really have on my map when I started to work on this, but when I got in touch with Kurt, who, as I said, is a deep learning specialist, and the people here in Berkeley had different topics on their mind compared to what I did back then in Hamburg. So they were all already in 2021 talking about these mysterious question and answer systems, and this is kind of what then turned into what we now see in ChatGPT. You have a system where you can ask a question and you will get an answer. How reliable that answer is of course a whole different matter, but this is a related question here, and I think philologists in a sense also have these question and answer needs all the time, and it could be very vague, just about passages talking about the Four Noble Truths, for example. That would be a very trivial case, but there could be more specific questions. And I think being able to answer those topical queries where we want to just retrieve all passages from a specific text that talk about a certain topic, for example, I think that's something that in the context of philology is an important question. Yeah, so this is the set of research questions that go into or that drive the development of this search engine. And our solution that we are proposing for this is the Mitra search. It has an interface that looks very similar to other search engines like Google, of course, and and others. And yeah, you have your ability here to enter a text. You can do some additional filtering by language, by category, and so on. So even down to the level of individual text. So you can limit your results to only from a very specific text, like only results from the Bhagavad Gita, for example. That is possible. Here is one example of how this search engine at the moment operates. So you can enter a query in English. Famous first verse of the Bhagavad Gita is the example that I choose here. So you can take a topical query, and then you will get your results that are matching that kind of topic. And here we have two results from the Bhagavad Gita. We can be fortunate that this has worked out in that way. So yeah, that's the experience that we are offering here. We also have these multilingual search abilities where you can find those matching passages across different languages. And here you can see a specific topic that came up in a reading group that we had earlier in Hamburg is about whether arahats, after reaching the stage of an arahat, can still lose their mind or go crazy. And actually, it's possible if the four elements are not in balance. And these kind of topical questions you can also bring to our system and then search across the different languages and see the parallel passages that are preserved in the different languages. So here, this is very handy in order to compare the renderings of this passage into from the Sanskrit into Chinese and into Tibetan. So for the kind of reconstruction work that I was showing earlier, having this kind of resource is extremely useful because one can immediately see how the different languages preserve this kind of information. Yeah, I think I can also give a short demo of how this search engine behaves. So you can type in your topical query. This is again something that is, I think, a quite famous verse from the Prasana Pada. It is also quoted in the Abhidhammakosha Bhashya. So you can enter your topical query in English and then you get the result. And here we have the result in Sanskrit, and then you can also create those explanations which are using a specific Mitra LLM in order to synthesize the search query and the response. And then you will get some kind of translation of this Sanskrit snippet together with an explanation of how that relates to the search query and how these work together. So yeah, in a way, it's a bit more constrained and guided than what ChatGPT, for example, does, because Claude and ChatGPT don't have that ability to retrieve specific passages and to actually lead the user to the source text and to give them the ability to interact with high quality e-text. Because with Claude and ChatGPT, as I guess all of you know, we are really at the mercy of the hallucinations that these systems are producing, while Mitra has the scope to really tie in the actual knowledge from the e-text directly. So it should be all grounded in real data and not just confabulating things. So just to revise to revisit this search interface that we provide. So on the one hand, there's this input field where you can enter your query. And then we have filter options, which are language, collection, category, and even individual text. So it's possible to only search in Shaiva literature or in epic literature or in Buddhist tantric literature. Those kind of topical decisions can be made, but also results can be narrowed down to just individual texts. And then we present the result in the form of the Sanskrit text first. So as I mentioned before, we really want to make sure that the users are interacting with the Sanskrit as much as possible. And also we have links here into a database that makes it then possible for the user to read the whole text and to see the context. And then we have these explanations, which are optional. And I mean, I'm myself, as much as I'm impressed by generative AI technology, I'm also concerned about the possible negative impacts of hallucinations. And in that sense, in our interface design, we try to minimize the impact of that. So those explanations, the user can generate them if they want to. They need to be taken with a grain, with a bit of salt, in a way that, you never know if this is really going to be always accurate. And that's, of course, also true for the machine translation system that we provide. And in a sense, it's not advisable to interact with either this search engine or the machine translation if you have no knowledge of the language. Yeah? And I would not recommend anybody to do that. Yeah, coming to the technical background, for those of you who are interested of how we are approaching this search system. So we start with the input query that could be something general, like what are the Four Noble Truths, for example. Then we have first the optional step of translation. So if the input query is already in Sanskrit, then we don't need to do that. We can directly search in Sanskrit. If the input query is in any other language, then we first need to make sure that we have the same language to search in. And then we have our retrieval section where we are querying a lot of different sources at the same time. So this follows a bit the approach that, for example, Perplexity, the AI search engine that is currently, I think, evaluated very highly based on the good performance that it gives. So we follow the approach of Perplexity in the way that we combine a lot of different search algorithms as well as different databases here. So we do a traditional BM25 search directly on the Sanskrit data. We also have Sanskrit data segmented into lemma with the help of our segmenter. And then we have KNN vector index to do semantic similarity search. We also do that kind of search on machine translated versions of the text. And in that way, we really have different nets, so to speak, like a fisherman that tries to catch as many fish as possible. We also have different nets in the water in order to make sure that we catch as many results that are relevant to a given query as possible. So that's this stage. Then we have the re-ranking and filtering module. So that is something, because we get a lot of results and not all of these results are good. And it's an ongoing challenge that we are facing with this system, is to filter out irrelevant results and to make sure that we only present those results that actually have an impact for the user. So that's the re-ranking module. And once we have passed through that, we can present the results to the users. And this could be, source text from Yogacara Bhumi, Atha, Vinishaya Sutra, and so on. So those results then are presented. And lastly, we have the optional step of doing that augmented generation. So here in Berkeley, many people are talking about so-called WAG system, retrieval augmented generation system, and Perplexity is a good example of that. And in a sense, we are building a sort of WAG system with an optional step of generation. So in our case, it's not directly part of the architecture, but it can be done. So if people want to have that experience, we are also offering that. How these vector embeddings actually are created, I can also give a short overview of that. It's a complex topic and it will probably go beyond this presentation here, but just for those of you who are interested, I'm giving a short overview of that. So we do have input text. This could be Prajnaparamita Sutra, Tantra Loka, or text in Chinese or in Tibetan. And the first step that we have to do, and that's actually more difficult than one might think, is to do text segmentation into reasonable units like sentences or paragraphs. So we need to break them down. And of course, the conventions in the different languages are different. So Sanskrit, Chinese, Tibetan, there are different standards on how to represent sentences. And this is therefore quite a challenging task. And even within Sanskrit, as we all know, the standards of editions does vary a lot. So some editions follow Western punctuations. In other cases, we only have the Danda as it is done in the manuscripts, which can be a very a sparse signal for segmentation. So in that sense, text segmentation is a bigger challenge for this project for sure. So that's really a greater challenge. And then, but once we have done that, we have done our segmentation, we can actually use the embedding model, which is a encoder-only transformer. Right now, we don't have a publication on this yet, but that's something that Oliver and I are currently working on to also give a scientific description of how this model is actually trained and functioning. So that will follow in the next couple of months. Once we have done this embedding, we create those paragraph representations. So we have vectors that represent a paragraph in numerical values. If that is a bit abstract, I can assure you that it's also abstract for me. I think the fact that text can be represented by numbers is fascinating, and these deep learning models, they are in a way they are fine-tuned to do exactly that. So the embedding model here is really trained in order to turn text into numbers, and these numbers then can be compared by using linear algebra. So we can use operations like cosine distance in order to determine how similar two paragraphs are, which is of course very handy, because then we can do standard mathematical methods in order to determine similarity of sentences, which is for a search system, of course, great. And there are special databases for this kind of search operations, where you can group the vectors into similar groups, and then the search becomes very, very efficient on large data sets. So we are using a KNN retrieval index here that makes the search on millions of these vectors possible in a very reasonable time. So that's the rough overview on how we turn those text units into numbers, and then we turn the numbers into a searchable index, and then we can use that in order to retrieve the search results. We are also working on the working title of this is Dharma Nexus. So I'm actually quite happy that we have been working on a Buddha Nexus 2.0 with Hamburg for a couple of years, and hopefully that will be released at some point this year or early next year. And that's an updated version of Buddha Nexus with a better interface and more reliable matching algorithms. So and Buddha Nexus, for those of you who are not familiar with the website, it provides an interface to discover similar passages across Sanskrit literature, as well as Tibetan, Chinese, and Pali literature. So it is a useful tool in order to find similar passages that are more or less verbatim with some variations. As you can see here, for this Sanskrit text, the Trimshika Bhashya, it's highlighting those similar passages with other texts. And we will also have a Buddha Nexus-like functionality in the Dharmamitra project. The working title for that is Dharma Nexus. And I think the biggest difference will be that we have different matching algorithms, because we have developed a little bit more sophisticated tools to create those matches. And also we have different data sets, because we have collected a lot of additional, especially Sanskrit data here in Berkeley, with the help of our interns and of David Elport and others. So we have considerably grown the data set, and that is something we also want to make available both in the Mitra search engine and in the Dharma Nexus application. And this is going to be tightly integrated with the Mitra search engine. So the search results link directly into the Dharma Nexus, which then gives the users the ability to explore the text collections and to find more of these intertextual links. So in a way, that's an intertextual exploration tool, first of all, with a good search engine that enables those topical queries and more distant queries. Yeah. Yeah, coming to the last part of my presentation, that's the Mitra LLM. So I will start with a description of the training data that we are using. So basically the Alaya LLM is the base model for the Mitra project. So that's the model that enables most of the other functions that we have. So in a sense, it really serves as the basis of this project. It is in size 5.7 gigabytes. That's roughly 7 billion tokens. When it comes to pre-training data, of course, compared to what Google, OpenAI, and so on are using, this is peanuts. It's quite small, but I think for an academic project that does its own machine learning, this is actually a sizable corpus. And in the size of academically realized continuous pre-training LLM papers, we are on the larger end. So this is actually really a considerable data set that we are using here. The English data is largely taken from OCR efforts on archive.org. So for that, we have just downloaded all the PDFs from archive that have India or Buddhism as a metadata tag. And then we have OCR'd them, and we have done some filtering on removing irrelevant text and low quality text and so on. And we have also done collections of openly available academic papers and so on. So all the kind of things that are in public domain, we have included that in this part of the data set. Then we have taken Tibetan and Chinese traditional data collections. So this is, of course, Buddhist scriptures and treatises. The ACE project for Tibetan in this case, and the Sebeta collection for Chinese. And then we have done our own efforts on creating a large Sanskrit data set. So we have combined different web resources like Gretel, Digital Sanskrit Buddhist Canon, as well as OCRs that we have done ourselves, also in collaboration with AI for Bharat. So they have released a very interesting data set earlier this year, where they have also included a large OCR of the Sanskrit data in archive. So that's it's a huge contribution that they have done. And we have included some parts of that data set. It's a very challenging data set because there's a lot of noisy, not always usable data in it. So the filtering is actually very challenging, but it's an ongoing project to see what we can do in order to also make parts of that data set eventually available in the search system as well. Yeah, and so we ended up with roughly 1.2 gigabytes of Sanskrit and Pali data combined here. And then we have parallel data here as well. I will explain a little bit later what this data set actually means. For those of you who have a machine learning interest, I will keep it brief, but I will give some details on how we did this training. So our base model is a Gemma 2 with 9 billion parameter in size. So that's on the smaller end of openly available LLMs that can do these kind of generation tasks like summaries, question and answer, and so on. So kind of ChatGPT-like abilities. Gemma 2 is a small model when it comes to that, but it's nonetheless, I think, larger than most models that we are usually using in NLP tasks. We have done a maximum length in the pre-training stage of 1024 tokens, which is, I would say, average. We could try longer, and that's also one thing that I would like to explore in the future to see if we can increase the token number for our models. Our effective batch size is 2 million tokens, and we have trained for 2 epochs. So one epoch is one pass of the entire data set through the model, and in this case, we have done 2 epochs, which is for these decoder-only generation models, I would say average. Maybe if you have enough data, you can do 1 epoch, but we don't have extremely much data. So we have a lot, but we don't have extremely much. So 2 epochs is a reasonable time. And we might see further improvements if we add another 1 or 2 epochs. So that's doable. We have done this on a cluster of 8 A100 GPUs. The training took 2 weeks for 1 epoch. So for two passes of the data set takes 1 month. If we want to do it longer, we will of course have to add another 2 or 4 weeks. So hopefully we can do some more training of this model in the coming spring with additional data that we are currently adding to the data set. When it comes to the approach of the training, just very briefly, we have tried different ways. So for those of you who have an NLP interest, this slide might be interesting. So we have tried to replicate this ALMA paper, which is not relying on any parallel data. So they only train on monolingual data and then use a very tiny set of parallel data examples. We were not successful to reproduce the results that they have. So for our data, it doesn't work. I guess Sanskrit is just quite difficult, or maybe not well represented in the base layers of the model. I don't really know what is going on here, but it was not possible for us to reproduce this. We are following the Tower recipe. So there's this one paper, Tower, an open multilingual large language model for translation tasks. And this is something that really worked for our purposes. So we have, our recipe is similar to that. It's not identical, but it's similar to that. We have also experimented with a range of openly available LLMs. So we have tried Llama 3.1, the Mistral family, but they are all not as good as Gemma 2. So probably the tokenizer efficiency of Gemma 2 is really good. And also the off-the-shelf capabilities on Sanskrit, on Tibetan, on Chinese is just really strong for Gemma 2. So for the time being, it seems that Google has the best model out here. We have also worked with MATLAB 400 in the past. So that was actually the first Mitra model. In the case you have used Mitra in April, May, June this year, you will have interacted with this model, which was a bit actually much smaller. It was just a 1 billion, 3 billion parameter model, so smaller and also more likely to hallucinate, and the whole quality was not as high as we have currently. So there's also kind of a learning process, not just on the end of the models, but also on the end of the people that train the models. So we learn what works and what does not work. And currently it seems that with Gemma 2, we have found a good solution. Yeah, coming to the training data into English that we are using in order to teach the model how to translate Sanskrit into English and other languages into English. So that's the rough overview of our data set. So we have about 2 million sentences of Tibetan into English. This has been done with Mernlam AI, a large NGO in India together. Then for Pali, we have worked together with scholars that some of them affiliated with Sutta Central. Then we have student interns and volunteer helpers at UC Berkeley for the Sanskrit to English data. So this 1 million sentences, we really collected them more or less alone here in Berkeley. So that was David Alport, myself, and a couple of students over roughly 1 year. And then we have, for the Chinese to English part, we have the support of Fo Guangshan, who are collecting data on that end. So yeah, that's how this parallel data is layouted. And then we also have parallel data for other target languages. And I think this is, for philological purposes, the very interesting data set. So based on our algorithmic solutions, we actually are able to automatically mine and align the Sanskrit and Tibetan data. So we can automatically identify which text of the Sanskrit is corresponding to which Tibetan translation, and then we can find all the individual sentence pairs between this. So in this way, we were able to find 600,000 sentence pairs between Tibetan and Sanskrit, as well as 280,000 sentence pairs between Sanskrit and Chinese, as well as 860,000 sentence pairs between Chinese and Tibetan. And I think for the research of the intertextuality of these languages, of the canons preserved in these languages, this is extremely valuable data. And as you can imagine, with this volume of data, we are also looking at a very different coverage compared to Polyglotta and other manually created resources, which is of course extremely labor intensive. And I have done that a little bit in my past. I have done manual alignment of these texts, and it's extremely time consuming and tiring. And therefore being able to just automatize that and give a whole corpus of Sanskrit literature on the one hand, 400 texts, and then the whole Tibetan corpus on the other hand, and just, you know, basically press a button and get all of these correspondences out in a couple of hours. This is really a wonderful thing. And it's going to be all integrated into the search system, as well as the Dharma Nexus platform to make this available to researchers. So this kind of data is not just useful for the training of these models, but is also extremely useful as a parallel reference corpus for philological research. Then lastly, I will just briefly talk about the instruction data set that we are using. So on the one hand, we have all of this pre-training data. We teach our model how to understand Sanskrit, how to reconstruct gaps in Sanskrit text. And then we still need to give the model concrete instructions in order to be able to solve specific tasks. And this is where we have this Mitra instruction data set here, which is used in the last stage. So after the pre-training for 4 weeks, we do a instruction training, which only takes a couple of hours and is done with a very small data set. And in our case, this is roughly 60,000 examples of different instructions. And what are these instructions. So on the one hand, we have translation and explanation. That is what I just showed earlier in the video, that we not only create an English translation, but we also provide an explanation of how that grammar structure and so on of the text of the translation and the input works. Then we do document level translation. So if you want to translate a whole page of a book or more than that, then we also have instructions of that in our data set. Then we also have KNN translation, which means we integrate existing examples from reference translations directly into the prompt. So in that case, we are not just saying, please translate this Sanskrit sentence into English, but we will say, please translate the Sanskrit sentence into English, and here are 5 examples on how you should do that. And only then the model is creating the translation. And this gives us a lot of steerability of the model. So we can decide on what data we input, and we can adjust the model behavior live. So otherwise, it's actually quite tiresome to improve the model. So frequently I get emails like, you know, everything works great, but on this specific text, there are some errors and I made some corrections. Can you please include those corrections into the model? And every time I'm a bit frustrated, because as much as I would like to do that, it's just not possible, because it would mean we need to retrain the whole thing for 1 month on the expensive hardware, which will make my colleagues very angry if I do that, because they want to use the hardware, of course. So in that sense, we need to be economical with all the changes that we make to this model. And KNN translation is a wonderful way of tuning the model behavior while it is deployed, while it is running on the server and actually serving users. So we only have to change those examples that we provide, and then suddenly the model will show those improvements in behavior. So that's a very useful capability. Then Dharmamitra, the Mitra LLM, is doing cross-lingual summary as well. So that's what I showed in the search video earlier, that we get a result in Sanskrit or in Pali and Tibetan, and then we not only translate, but we summarize at the same time, and we also give somewhat of an explanation on how that result relates to that search query. So that's kind of a cross-lingual summarization and explanation task. And then lastly, we also do cross-lingual term extraction. So in that case, we have 2 paragraphs. So one is in, for example, in Chinese and the other in Sanskrit. And then we give an input term, for example, Dharma, and then the model needs to find which words in the Chinese and which words in the Sanskrit correspond to Dharma. And in that way, for those who are working with bilingual text, who need to look up all those correspondences, they can use this cross-lingual term extraction efficiently to find all of those word pairs across the languages. And this, of course, opens big possibilities to create an automatic dictionary for example, Sanskrit and Tibetan, or Sanskrit and Chinese, which goes beyond what manually crafted dictionaries like Negi, for example, have done so far. So with these capabilities, we can actually automatize the creation of the ground data for these kind of dictionaries. Of course, there will be some human post-processing needed, but it's going to open up the possibility to build these resources much faster than doing it all by hand. Yeah, for those of you who are interested, I can give a very brief overview of how this translation and grammatical explanation engine in practice works, that we are going to release in the next 2 weeks. And that is also part of this KNN translation and explanation capabilities that are included in the instruction tuning step. So we start with the Sanskrit input sentence, and then in the first step, so before we put this into the actual LLM, the Mitra LLM here, we do a Sandhi splitting and lemmatization and morphosyntax tagging with the model that I presented earlier at the beginning of the presentation. So that's one thing we do. And then we create a draft machine translation with our model. And then what we do next, we also take the Sanskrit input sentence and use the search engine in order to find similar passages from our Sanskrit English data storage. And in that way, we can generate a set of examples to show the model. And then we can combine all of these different resources into one prompt. So we can say, here's a Sanskrit sentence, that's the grammatical structure and explanation based on our model. Here is a number of examples from the data storage. And now please provide a translation that works with all of these different resources, and also give a grammatical explanation. And that's how this ability to not only translate, but to also explain how that translation comes into existence, how the different words relate to each other, and so on. That's possible by combining basically all of the different elements of the Mitra ecosystem that I have presented in the previous slides. Yeah. And yeah, hopefully we can make this publicly available in 1 or 2 weeks from now. We are just solving some remaining smaller technical issues here. Yeah, for those of you who want to play around with this LLM and see how it performs, you can actually download the model on Hugging Face. We have our organization there, which is called Buddhist-NLP. And yeah, it's open, everybody can download it. And if you want to build your own applications, then feel free to do so. Yeah, what are the future perspectives of the Mitra project? I want to just very briefly give an overview of that. So on the one hand, I mean, combining translation and search more tightly, that we give not just the translation, but also some possible references of similar passages, and give the user the ability to explore them directly. So you can click on links that are following the translation, and then the user can look into the database and see what kind of similar passages we have. This is something that actually people requested quite a lot so far, and I would be happy to add that at some point. Then another thing that is, I think, also for Sanskrit, especially for philological applications, very interesting, is to do a sort of spell and grammar checking of the input. I do know from my own experience that it's not easy to type Sanskrit without making mistakes in the diacritics, especially if you are not somebody who has like 10 hours a day to spare to do that, to read Sanskrit. So my ability to type Sanskrit is limited. And for that reason, I actually already earlier trained a model that will reconstruct diacritics in case they are placed wrongly. And this is, I guess, something that could improve quality of editions quite a lot, because obviously sometimes surprising how many of these typos actually make it into printed editions. And I think there's a whole opportunity here to sanitize and to validate Sanskrit input before we actually publish these works. And then, of course, this also leads into an application that could be called the philological co-pilot. So I know we have a lot of controversial ideas about what AI is and what it isn't, and whether it's sentient or not. It's all very philosophical. I might not be the right person to answer that, but I'm happy to give a controversial take of what a philologist might be. And in my view, maybe philologists are just human LLMs that are trying to reconstruct language based on the experience that they have made doing the learning of this. And in that way, I do believe maybe LLMs are not the wrong answer to the question on how to do philology properly. So in that way, we can actually use LLMs and train them on masked token prediction, which is basically the task where we hide a certain part of a sentence, and then the language model has to reconstruct what is behind that mask. And in that way, I think we have a training paradigm that is actually very similar to the task of reconstructing gaps in manuscripts. And in that sense, we can do, of course, a freestyle task where we say, okay, we just mask and please reconstruct. But of course, people will object, and I can already see maybe somebody here will type in a question and say, no, 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 we have all the other evidence. What about the photograph of the manuscript? What about parallel passages? What about all of this? And I totally agree. I mean, that's obviously extremely important. And one step at a time, we can try to integrate those capabilities into the model as well. I think the easier part is to use parallel passages and possible variant readings, including photographs of manuscripts, is naturally more complex because that requires multi-model training of this model, but it's absolutely doable. And I really see a future where we are going to work with LLMs also in what we might call hardcore philological tasks very closely. And in that sense, yeah, I think there are great opportunities here to tackle with these kind of tools. And lastly, and to come back to the Madhyanta Vibhagatika manuscript and the question on how much of that we can automatize, my own take of this, and I might be a bit controversial, maybe people will disagree, I'm happy to argue about this. My own take is that probably 70 to 80% of the philological work that we are doing might be largely automatizable, because LLMs are just really good at retrieving more distant relations in a graph. So we humans have rather limited capabilities to do that. We are able to recall something that we have read the day before. Maybe if we have read a lot, people have amazing memories, they can recall much more. But ultimately, a computer model that has 20 gigabytes of data seen during the training process of Sanskrit will just ultimately be better at retrieving that. And that's, I think, in the long term, something that we need to be aware of. So I think when it comes to most of those more or less trivial decisions in editing a text, I do believe that LLMs will do quite well on that. But on the other hand, given the fact that we have principles like Lectio Difficilio, I would say maybe 10 to 20% will remain really hard, and no computer is going to do that for us. So when it comes to really making decisions on difficult problems, this is something where I don't see LLMs being useful, neither in the near nor in the more distant future. So my answer to the question, can we automatize this? I would say yes and no. We can automatize a lot, and we can provide possible solutions to these philological queries. But I would say the decision in the end, which reading is really the best one, that's probably something that humans ultimately will stay involved in for a longer time. Yeah, but I'm happy to hear diverging opinions on this. Thank you very much for giving me the opportunity. I think that's all I have for today, and thank you very much. Yeah.